Hello and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapter 11.1, Hacking Wireless Networks. Please like, subscribe, and hit the notification bell. Now, let's right into the first topic, after this short break. The term wireless generally describes equipment and technologies operating in the radio frequency spectrum between 3 Hz and 300 GHz. Examples of wireless equipment include cell phones, smartphones, AM/FM radios, wireless networking devices, and radar systems. Most wireless networking equipment operates in a smaller portion of the RF spectrum, between 2.4 GHz and 66 GHz. Wireless technology, especially on the Internet of Things, continues to grow in popularity, which has made securing wireless networks from attackers a primary concern. This module gives you an overview of wireless networking technology and standards, explains the process of authentication, describes war driving, and covers some tools attackers use on wireless networks. Now let's burn on into the next topic, right after this short break. For a wireless network to function, you must have the right hardware and software and use a technology that sends and receives radio waves. At one time, when seeing the comic strip character Dick Tracy talk to his wristwatch, people wondered whether that would ever be possible. The idea that a phone could work without a wire connected to it seemed astounding, even though Alfred J. Gross had invented the walkie-talkie in 1938. In fact, the creator of Dick Tracy asked for Gross's permission before using a wireless wristwatch in his comics. To read more about Al Gross, visit www.retrocom.com. In 1973, 35 years after the walkie-talkie, Martin Cooper invented the first cell phone, which weighed close to 2 pounds. Wireless technology is part of your daily life. Here are some wireless devices many people use daily: baby monitors, keyless entry systems, cell phones, smartphones, global positioning system, GPS devices, remote controls, garage door openers, two-way radios, Bluetooth-compatible devices such as smartwatches, speakers, and headphones, smart TVs, and smart cars. Now let's bust a move on into the next topic, right after this short break. Components of a wireless network. Any network needs certain components to work: communication devices to transmit and receive signals, protocols, and a medium for transmitting data. On a typical LAN, these components are network interface cards, TCP/IP, and an Ethernet cable, which serves as the connection medium. As complex as wireless networks might seem, they too have only a few basic components: wireless network interface cards, WNICs, which transmit and receive wireless signals, and access points, APs, which are the bridges between wired and wireless networks. Wireless networking protocols, such as Wi-Fi Protected Access, WPA, a portion of the RF spectrum, which replaces wire as the connection medium. The following sections explain how an AP and a WNIC function in a wireless network. Now let's sprint on into the next topic, right after this short break. Access points. An access point, or AP, is a radio transceiver that connects to a network via an Ethernet cable and links a wireless LAN to a wired network. Some wireless networks do not connect to a wired network, such as peer-to-peer networks. But this topology isn't covered because security testers are seldom contracted to secure a peer-to-peer wireless network. Most companies conducting security tests use a WLAN that connects to the company's wired network topology. RF channels are configured in an AP. Hackers look for APs as they drive around with an antenna and a laptop computer scanning for access. Channels are explained in more detail later in the 802.11 standard. For now, think of a channel as a range or frequency that data travels over, just like a channel on the radio. Now let's slam on into the next topic, right after this short break. Service Set Identifiers. A Service Set Identifier, or SSID, is the name used to identify a wireless LAN, much the same way a VLAN ID is used to identify network VLANs. An SSID is configured on the access point as a unique 1 to 32 character case-sensitive alphanumeric name. To access the wireless LAN, the access point connects to wireless-enabled computers must be configured with the same SSID as the access point. The SSID name, or code, is attached to each packet to identify it as belonging to that wireless network. The AP usually beacons, broadcasts, the SSID several times a second so that users who have WNICs can see a display of all WLANs within range of the AP's signal. The SSID is broadcast in clear text, unencrypted text, which can be a security issue. Anyone who detects the SSID of the AP can attempt to connect to it, including hackers. To better secure your AP, you can disable SSID broadcasts so that only people who know or guess the SSID can connect to it. Some WNICs come with built-in wireless connection software that looks different from the Windows utility. Many vendors have SSIDs set to a default value. For example, Cisco APs previously used the default SSID Tsunami. Typical default SSIDs are single words such as wireless, Netgear, Linksys, admin, and default, though default SSIDs can change often. As a security professional, you must research constantly and gather information to keep abreast of changes in this industry. If an AP is configured to provide its SSID after authentication, wireless hackers can attempt to guess the SSID by using a well-known default SSID. Make sure your client isn't using a default SSID. Sometimes, a default SSID can tell an attacker that the target AP is old or out of date. If a wireless AP is using the default SSID, it might also be using other defaults, such as the default username and password for the administrative login. If hackers wanting to access an AP find a default SSID, they will try the default administrative login credentials first. Now let's drop on into the next topic right after this short break. Finding vulnerabilities with default SSIDs. As you learned earlier, recognizing which operating system a customer or client is using is essential before you can detect vulnerabilities in a system or network. This is also true when you're attempting to discover vulnerabilities in an AP. When conducting a security test on a WLAN, you start by looking for SSIDs advertised over the air to determine the type of AP the company is using. If necessary, start your computer in Windows or boot into Kali Linux and start a web browser. Go to. In the left pane, click Search to go to the search page. On the search page, click the Vulnerabilities CVE button to go to the Search Vulnerability Database page. Type DLink Wireless in the keyword search text box and then click the Search button. Review some recent vulnerabilities with a common vulnerability scoring system, CVSS, severity score of 9 or higher. Click the CVE link and read the vulnerability summary information to learn more about each critical vulnerability. Is an exploit or attack demonstration available? Does the router use a typical default SSID? Because router models and URLs change constantly, use your search skills to find the default SSID for the router make and model you selected. What solution would you offer to a client using the router you selected in Step 3? Now let's zap on into the next topic right after this short break. To send information over any medium, a computing device must follow the rules for the medium it's traversing, so the correct software and drivers for the NICE must be installed. For example, data traveling over a copper wire must follow rules for how Ethernet signals are sent over that medium. For wireless technology to work, each node or computer must have a WNIC, which converts the radio waves it receives into digital signals the computer understands. There are many WNICs on the market, but be careful deciding which one to purchase if you're considering using specific tools for detecting APs and decrypting WEP keys, or using antennas that can cover a large distance. For instance, air cracking, a program for cracking WEP encryption on a WLAN, requires using a specific chipset on a WNIC, so only certain brands of WNICs can be used. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.